Alright, so this is year 11 Mathematical Methods lesson 26. We start a new chapter called Probability. So the first section for probability will be language of events and sets. Okay, so for the first three lessons, possibly many things you have learned from your year 10 probability, but still you need to be careful about some more complicated questions and all the new notations and the way we express our probability arguments. Okay, so let's start. Okay, so first we need to introduce some set notations because we are going to use set notations to talk about probability. And so the third thing is about a set. Set means a collection of numbers, objects, anything, right? So normally for set notations, you need to write something like this kind of bracket. Okay, it's curly bracket. Okay, then here's an example set of outcome following a die. So 1, 2, 3, 4, 5, 6 will be the set. Alright. So sometimes there's an empty set, means that there's nothing in the set. We just write things like a 0, but with a stroke cutting through the 0. Alright. And the next thing is what we call union. Okay, so if we have two sets, so set X and set Y, if we got two sets and you got a union of two sets, okay, so that's U looking symbol means union. Okay, for this symbol, if we call union, then obviously you join all the elements in two sets together, okay, to highlight what do mean by unions of two sets. Okay, so suppose you see a rectangle. Okay, so that rectangle means the larger set, what we call universal set. Okay, so normally we use U or another symbol, okay, in the book, which is a Greek letter, but we use U at the moment. So this is what we call a universal set. Universal set. That means all the things in that context we are considering. Okay, so in that universal set, that's two sets we call X and Y. If you want to do the union of two sets, what happens? That means you collect all the elements within the two sets. So I shade both circles. Alright, and the other method to join the two sets is called intersection of two sets. Okay, intersection. Okay, so you see the symbol looks different. Okay, it's upside down of the union symbol. Okay, so this is the symbol. Okay, for this intersection of two sets, which area are we going to use to represent that intersection of two sets? Okay, it's going to be the area between the common area between X and Y. Okay, so intersection means you just collect the elements which are common to both sets. Okay, union means you collect all the elements from the two sets. Okay, so they are different, right? Another thing you need to learn is what we call a complement of X. Complement of a set means the rest of that set. Okay, so normally we use X and a dash here, or sometimes in the book you might see things like this, a bar in front of it. Alright, or you just sometimes we might use word not X to represent the idea that's not in X. Okay, that means complement of X. Okay, how could we represent this? so not in X. Alright, so that means here or around here and also here. Okay, so that means all the elements except those in X. Alright, okay, so that's what we call complement of X. Okay, sometimes we are doing complement of X in Y. That means that's in Y, but you take away the portion which is also in X, so that's only this portion. Okay, so that's in Y but not in X. That means the complement of X in Y. Okay, but this is not that popular, so you just possibly just have learned it a little bit. That will be alright. So sometimes we call one set is the subset of the other. Okay, for example, when X is a subset of Y, what does it mean is that X is totally within that Y. Okay, okay, for the symbol, it would be okay if you just write that symbol, or in the book you might add one more bar under that symbol. Alright, okay, so that's kind of symbol you might use. Okay, so here are some symbols in the book. Alright, so some of them we have covered. Okay, so the first one, X belongs to A, so that symbol means belongs to, means X is an element of A. If you cross it, that means X is not an element of A. Okay, also the universal set. So normally I use U, but the book use this is what we call epsilon, which is a Greek letter. Both are okay, right? In the examination you use whatever you like. Okay, so let's have some example. List all the elements in the following set. So I need to list all the elements. Okay, so for X is a factor of 20. Okay, so what are the factor of 20? Of course, 1 is a factor of everything. 2, alright, and because 20 is divisible by 2. Okay, and 3, how about that? 3 is not. 4 is. 5 is a factor. And then the next factor will be 10. Alright, because 2 times 10 equal to 20. Also 20 itself. Okay, so here are all the factors. When you list out the factor in a set, you just list out that with that kind of that's curly bracket on both sides, right? And Y is a positive integer less than 10. Okay, positive even integer, positive and even integer less than 10. Okay, it must be even number, so 1 is not, 2, 4, 6, 8, 10 is not, because less than 10. Okay, that's it. Okay, sometimes it's not necessarily number, it could be symbols or objects. Set of outcomes of a tossing a coin. Okay, a coin have two kinds of outcome. One is head, the other is tail, right? Okay, good. Okay, so let's have a bit of revision on Venn diagram. Still remember the Venn diagram? Okay, so Venn diagram is a diagram which show you the elements within some sets. All right, so normally we draw a box, rectangular box, which represents the universal set. In probability, sometimes we call that sample space. Okay, and normally that 2 or 3 circles representing different kinds of subsets of that in that universal set. Right? Okay, so list all the elements. All you need to list all the elements of the set and find the number of elements. Okay, so what kinds of symbols shall we use when we are going to find the number of elements? You need to use this symbol, and bracket the set. That means the number of elements in that set. Alright, for U, okay, U means all the numbers in that rectangle. It should be 1 to 10, right? Sorry. Okay, how many of them? Of course, you got 10 elements, so you write n bracket u equal 10. Okay, x. Okay, x means all the elements in the circle for x. 1, 2, 3, 6, 7, 10. Okay, number of elements in x, there's 6 of them. All right. Okay, y dash, that means y complements, that means all the elements which is not in y. Okay, not in y. All right. Okay, so you have to take away all the elements in y. All right, so that left behind is 1, 2, 3, 6. Okay, 7 is in the common area of x and y, so that means it belongs to y as well. Okay, and 8, 9. Okay, so there are 6 of them. Make sense? Okay, and alright, so then we are going to do the union, x union y. Okay, remember union, we collect all the elements in the union. Alright, and for the union, we collect all of them. So you got all of them except that's the outside the circle of x and y, which is 8, 9. 1, 2, 3, 4, 5, 6, 7, 10. Okay, so except 8, 9, so there should be 8 of them. Okay, so still remember this? That means the intersection. That means in both x and y. That means the common area. Okay, normally intersection give you a smaller set. Okay, 7, 10. Okay, so it's 2. All right, x and not y. Okay, so it's intersection between x and not y. Okay, let me put it here so to have a better look. Okay, so first we need to think about what's not in y. So not in y means the area here, not in y. Alright, okay, but at the same time you need to be in the x. Okay, so not just not in y, but you need to be in the x. So if that's outside x, then it should not be included in this side, right? Okay, so where it should it be? All right, so it should be in the x but not in y. All right, should only be here. Okay, so the element should be, all right, the set should be 1, 2, 3, 6. Okay, so there are 4 of them. Okay, the last one. Okay, so this one's trickier. So not in x and also and union not in y. Okay, all right, so let's see if I still get this diagram over here. Okay, let me put it here. All right. Okay, so what we're going to do is at least a bit of space, right? Okay, first let me see not in x. Okay, so these are the thing which is not in x. Okay, but you need to find those not in y as well. Okay, so let me copy another thing. Okay, let me have another one. Okay, so the yellow is not in x, so this one is not in x. Okay, let me do one which is not in y. Not in y means this one, right? Okay, so this is not in y. Okay, so remember you need to collect all the data, okay, not in X and not in Y. Sorry, not in X, but all the data in either not in X or not in Y. Okay, so it's quite complicated. So simply put, you need to collect all the elements in the yellow shaded area or the blue shaded area, all right, to make a union. Remember now it's union. Okay, so you need all the data in the yellow area plus all the data in the blue area. Okay, so that basically you only exclude that's 7 and 10, right? Okay, so that basically what we're going to have is 1 2 3 4 5 6, no 7, 8, 9, no 10. Okay, so there are of course 8 of them, right? Okay, that's how we do it. Right, so this one we are going to use letters, right, rather than numbers. Refer to the Venn diagram of letters A, C, H, K, N, O, P, R, S, T, U, W. Okay, alpha is the set of all letters in north. Beta is the set of all letters in the south. Okay, so you need to construct a Venn diagram including set alpha, beta. Okay, how could we construct a Venn diagram? Okay, remember to construct a Venn diagram, you need to draw a universal set, which is a rectangle. Okay, then you need to draw 2 circles representing that's alpha and beta, right? To draw 2 circles, which is alpha and beta. Okay, the size of the circle doesn't matter, right? Okay, let me label it. So this is called alpha, this is beta, so this is U, which means all the letters. So how should we fill in the Venn diagram? So remember, here's the key. Always, okay, so let me remind you. So here's the key. Fill the intersection part first, if there is one. Okay, so fill the intersection part first. So you need to fill which part? You need to fill this part first. Okay, so this part means alpha and alpha intersect beta. So you need to fill this part, alpha intersect beta. Also, you need to look for what kinds of letters are common to both alpha and beta. Remember, alpha is set of all letters, all right, in north, beta is south. Okay, so between 2 words, what letters are common? O is one of them. Okay, T the second, H. Okay, so there are 3 letters which are common to alpha and beta. So that means in the intersection of alpha beta, you will get O, T, H as 3 of them. Okay, so all you need to do now is write O, T, H right here. Alright, and then you fill in the circles. Alright, so if for alpha, if O, T, H is already written down, so all you need to do is write R, N and R. For beta, what you need to do now is south, S and U, right? Okay, right, so and then all the letters are outside the 2 circles. Okay, of course A is not inside our circles, C is another one, H is there, K, N is already inside, O is already inside, P is not there, R is already inside, S is already inside, T is already inside, U is already inside W. Okay, all good. Then the rest of them are very easy. For example, number of, so you see n, that means number of elements in the union of alpha and beta. Union of alpha beta means which area? Means all this area, right? So there are 1, 2, 3, 4, 5, 6, 7. There's 7 of them. All right. Okay, so you just write 7. Okay, and this one, be careful. There's a dash. That means this is complement of alpha and beta. Okay, so what do we mean by complement of alpha union beta, right? So first, let me see the complement of alpha. That means, okay, outside the alpha, and you need to union that beta. So you should include all the data within beta as well. Okay, so are there some letters outside the yellow region but still inside the beta? Should be these 3, right? So you should include these 3 as well. Okay, so all the letters in the shaded area is now in that union between alpha complement and beta. So how many of them? 10, right? So 10 of them, right? Okay, all good. Okay, and here union, sorry, that's intersection between alpha and beta. So intersection between alpha and beta should be only 3 letters, OTH. So that's 3 of them. That's it. Okay, so this one, intersection between alpha and what? Complement of beta. So all the element in the common area between which are common to alpha and the complement of beta. So it's a bit tricky. So let me copy the diagram over here. Give you. Okay, first let me think about, because we are going to do intersection, so let me do it into 2 graphs to have a clear explanation for it. Okay, it's not that good. I need to move up a little bit. Okay, next one, more room for it. Okay, first we need to see alpha. Okay, alpha is easy, just the green color. Okay, not in beta, which is complement of beta. Let me use yellow, not in beta, right? So everything not in beta. Okay, so you need to do the intersection. So that means you need to find the common area of the 2 Venn diagram. Okay, because this is an intersection, you are not going to find all the area shaded. You just need to find the common area, okay, with colors in both diagrams. Okay, so because you are going to do intersection, okay, so which part do you see are common to the both diagrams? And you see it should be here, right? It should be here, right? These are the areas that are common to the both graphs. Okay, so number of them should be only 2. That's it. Okay, so remember, sometimes it would become difficult for intersection. Intersection for me is more difficult than union. Union, you just collect out whatever you shaded, but for the intersection, you need to find, you need to shade in 2 separate Venn diagrams, and you just compare to see what are the overlapping area for the both Venn diagram. Then that would be the answer, right? Okay, let's move on. Okay, so here are some exercise of the intersection and union. Okay, so right, so it's not that difficult. Alright, so for intersection, remember, so here we don't have a Venn diagram. Do we need to have a one? Of course, you can always draw the Venn diagram, but actually for this kind of data, we could try not to use Venn diagram. We can still do it. Okay, for example, for A, if you are going to do intersection, you need to find the common element in both sets. Okay, right? So we can go one by one. Okay, 6, is there 6 B? No. So 6 is not the common one. 12? No. 18? No. 24? Yes. So 24 is the common element. It's a common element in both sets. Okay, 30? No. 36? No. 42? No. 48? Another one. So there are 2 common elements in both A and B. So the intersection of A and B, just these 2. Okay. Alright, so I'm not finishing. Okay, so how about union of A and B? So for union, you just need to copy all the elements in both sets, but don't repeat copying those in the intersection of 2 sets. Okay, so for example, you can copy 6 and the next one will be 8. You just copy whatever they are. Okay, so because union means you collect all the things. Okay, 6 is in A, B is in B, and next one's 12 and then 16 and then 18. All right, and then should be 24. Okay, but we only copy 24 once. All right. Okay, and 24 next to 30, and 30 after that should be 32, and the thing is greater than 36. And how about 40? Yeah, 40, 42. Then should be 48. Only copy 48 once. Okay, so here is a long list of that union or between 2 sets. Alright, so let's do boy. Okay, so you might try to do it, then we compare our answers. I just need to make sure you understand what do we mean by the intersection and the union. That's it. Okay, so let's see the answer. Alright, okay, it's not difficult. You need to find the intersection first. Okay, find the common letters in both sets. Alright, okay. Okay, so next question is about, okay, so sometimes the question does not ask you to do Venn diagram, but constructing a Venn diagram will really help you to find a number of elements in each set. Alright, so let's see. If I have a group of 50 students who will ask what they did on the weekend, a total of 35 said they went to concerts. 22 said they went to beach, and 5 of them said they stay at home. Okay, so the first question, how many students went to both concerts and the beach? Okay, so if you just look at the question, there are 4 numbers. 50, which is the total number of students. 35 is number of students going to concert. 22 is number of students going to the beach, and 5 of them staying at home doing nothing. Alright, so but if you add all these numbers together, what do you see? You will see the number actually is greater than 50, right? So it's 62. Alright, it's 62. Alright, so that means 62 is greater than 50. So that means that some students, okay, go to both concerts and the beach. Alright, so so that's why we ask the first question. Okay, so let me draw. There are many ways to do it, I have to admit, but let's do it properly by drawing a Venn diagram first. Okay, so first we understand. So that's universal set U with 50 students in total. Alright, so here's the set of concerts and also set of beach. Alright, so concert and beach, we use C and B to represent two destinations, and also some students stay at home. So stay at home, that means they are not going to they did not go to concert or beach, right? So there are 5 of them, right? Okay, so how could we construct this? Like what we've done before. Okay, so in the previous question, I remind you, whenever you do your Venn diagram like this, the key is always fill the intersection part first. So I'm going to use that key again for this question. I'm going to use that again. Right, fill the intersection part first. Okay, but you say, okay, so intersection part is exactly what we're going to find. We don't know it. So if you don't know it, you put X right here. Okay, so we know now 35 students going to concert, and X of them also went to beach. So that means, okay, there are 35 take away X students who only went to concert but not the beach. And also there were 22 minus X students, okay, who only went to beach but not concert. Okay, so you see, I got each part of that Venn diagram is sort of an expression, if not a number, right? And you know, because the total of them is 50, so all you need to do now is add all these numbers together, okay, and you will get the answer. And because total number is 50, okay, so if you solve the equation, you got X, right? So all you see now, that minus X plus X is 0. So that's 62 minus X equals 50. So X actually equals 62 minus 50, which is 12. Okay, so that 12 students who went to both concert and the beach, right? Okay, so you see, actually there's some interesting aspect. If you just add all the numbers together, you got 62. If you use that 62 to take away 50, you got 12 as well. Okay, so actually there's a quick way to get the number, right? Why? Because when you add all the numbers, you add the circle C, the circle B, and what left outside the circle. But then when you add circle C with circle B, the intersection part, I mean the part which is common to both circles, you add 1 extra time. Can you see that? Okay, so what more than 50 is actually equals the intersection part. Okay, so that's why when you add all the numbers together, you take away the total number of students, you will get the intersection, the number of students in the intersection part. Alright, okay, good. And how about how many students did not go to the beach? Okay, so let's say we use some set notation and not go to beach. Okay, it's like B complements. Not going to beach, there are 35, take away 12 plus 5. Yep, okay, so outside the circle B, right? So there are how many of them? 28. Alright. Oh, good. Okay, so this is question 5. Okay, so actually this I think this is not a lesson. Possibly in a face-to-face lesson, I'm going to only use like 30 minutes or 40 minutes to finish this, or I might not have time to teach you this, might just make a video to ask you to watch it at home like what you are doing now. Okay, so because all these things are too easy for and they are too familiar for most of you, and they are from year 10, but still we need to do a bit of revision. Don't worry. Okay, so anyway, please try to do some exercise. You don't need to do all of them, like the first one, the set of letters. Okay, so I think this just too easy. Okay, you might do something like this 7, okay, if you want, or 6 about the union intersection things. You might try to practice a little bit more. Okay, like this kind of symbol, possibly you need to have some practice. Alright, like question 12 is interesting exercise as well. Okay, that's what you need to do, and we got answer in the handout. Alright, so this is just a bit of revision. So next video will also be best part of that will also be revision. Alright, okay, so see you next time. Bye bye.